Hello, this is Jim Gordon, Treasurer for Citizens for Regional Transit. This is Part 4 of the continuing series on the University at Buffalo's School of Architecture, Small Bilt Works, Vision 2024 proposal. CRT appreciates and gives thanks to WBEN 930 AM radio for permission to rebroadcast the audio that they recorded. This is a replay of Professor Brad Wales' Architecture 404 class community presentation of May 15, 2024. The Vision 2024 proposal consists of 3 light rail rapid transit lines: the Bilt Line, the Kensington Line, and the Airport Line. Part 4 introduces and features the students from Brad Wales' class. Early in the semester, students looked at existing rail stations from around the world to use as precedents for designing their own stations.
Hi, my name is Yolanta. I did a precedent study on the Train subway station in Sweden. It is one of 3 new stations. This is a good example of design station that doesn't take away from the local architecture.
Good evening, everyone. My name is Wei Ji. I did a precedent study on the Biltmore Arena station located in Biltmore, Amsterdam. This project was a great example of how public infrastructure can contribute to the growth of a community and neighborhood, and also promoting economic development.
My name is Mark Chen, and for my precedent study, we looked at the Barneveld Noord station in the Netherlands. And we looked at this station because it was on the other end of the spectrum of the other stations. It was a really small station that uses unique materials like shipping containers.
Hi, my name is Andrew. This level crossing removal precedent is a great example of what we're trying to do here in Buffalo. The elevated tracks decrease typical car traffic caused by level crossing. We also studied to mimic the same structure used in this project. Canopy structure was also further researched to use in our project to provide cover for those in non-ideal weather conditions, as you can see in this image here. This project was also used with prefabricated materials, allowing for faster production on site, and it is also cost efficient. Most stations were heavily inspired by this precedent.
Hi, I'm Josh, and this is the South Morang Rail extension, also in Australia. And these are good examples of train stations designed as civic architecture. And then this here is a proposed train station in Chicago, which uses this covered ellipse, which inspired a ellipse in our projects, which is used in several of the train stations, which you'll see later.
Hello, I'm Jared Yost, and I was tasked with analyzing Napoli Aftergola Station by Zaha Hadid. This was due to its design as a landscape architecture connecting the national side, rail side, and the local side, as well as erasing foot traffic across the tracks in order to increase efficiency.
Hello, I'm Bryce Perez, and I was tasked with studying the Millennium Line in Vancouver, British Columbia. So I studied 4 different stations, all of different scales and sizes. But one thing that we took from this was the reuse of materiality, so they become a wayfinding device.
Hello, my name is Halongo. This is the Fortaleza subway station, more specifically the Popik station itself. This is a good example of connecting 3 modes of transportation, pedestrian, metro, and bus terminal by extending the pre-existing 1-story station up 1, connecting it to the pedestrian bridge.
Hi, I'm Jeff Walker, and my station was the João Paulo Marubi station in Brazil. It combines several modes of transportation to allow for different people to access it different ways. And it has an underground mezzanine to allow access to both sides of a metro station, which is something I used in my project, which you'll see later. Throughout the semester, we received various presentations
rounds of feedback from Jeff Ampleman, who is the project manager for the NFTA extension of the Buffalo Metro line. Currently ends at South Campus, and then it's going to extend up to North Campus. A big part of transit-oriented design is allowing pedestrians and bicyclists to access the stations. So this comes in the form of sidewalks and bike lanes. Also focuses on interconnecting different modes of transit, so people can access it, say, by walking or parking their car and taking a train or a bus. This is a rendering of the Boulevard Mall station, which is currently in the process of being developed, as we talked about earlier. This is a above-ground station in downtown Buffalo. This is the ground floor of the NFTA Medical Campus Station. You can see the public artworks, which sort of brings a level of liveliness to the station.
Hi, this is Jim Gordon, Treasurer of Citizens for Regional Transit. We're going to talk about two of the very many benefits of light rail rapid transit. Let me start by defining what we mean by light rail rapid transit. These are train cars traveling at 50 miles an hour or faster. They are steel-wheeled vehicles on steel rails that make no greenhouse gas emissions or microplastic emissions from operations. They have no conflicts with cars, bikes, or pedestrians, and they're fed by feeder buses at each station. Buffalo's Metro rail system operates in two different modes. There is a light rail rapid transit mode that operates underground between UB South Campus and Tupper, and a streetcar mode which is restricted to speeds 15 miles an hour or under, starting from Tupper Street all the way down to the harbor, downtown. This picture compares 140 cars with 140 people versus a single light rail rapid transit car with 140 people. Notice how much space it takes on the highway to fit 140 cars. Yet these cars are parked. If they were traveling 30 to 40 miles an hour, there would need to be 3 to 4 car lengths in between each of the cars, which would increase the total amount of space required by the cars by a factor of 3 or 4. Yet every day under Main Street, we have thousands of people riding Metro Rail, and they're putting 0 cars on the street, resulting in Main Street being congestion-free. Here's something a lot of people don't know. Buffalo's 2-track Metro Rail system has the same maximum carrying capacity as the Kensington Expressway. A high-speed expressway like the Kensington Expressway can carry 1,000 cars per hour for each lane of highway. Each car represents a person, so that's 1,000 people per hour per lane. The Kensington Expressway is 6 lanes, so the math is very simple. 6 lanes equals 6,000 people per hour is the maximum number of people that can travel down the Kensington Expressway at a time. Now let's do the capacity calculation for Metro Rail. Each train car can carry 140 people, and Metro Rail can put 4 cars together to make a train. That's 4 times 140 people, or 560 people on each train. Metro Rail can run, and typically does run, 10-minute headways during busy times. That's 6 trains per hour. 6 times 560 comes to 3,360 people going on a train in each direction. 3,360 times 2, that's 6,720 passengers per hour, which is just about the same as the Kensington Expressway's maximum capacity. The point of this is to make sure Metro Rail is included when planning and conducting highway traffic studies. Currently, this is rarely done. Yet, Metro Rail can prove to be a much more cost-effective way to move people around our region than highways.